In this video, I want to reinforce the concept of heat load calculations being a multi-step process, where the number of steps required is determined by where you start and where you end the heating task. What I mean by that is, are we simply adding sensible heat within one state of matter, such as liquid, or are we heating the matter so that we change states as well as the temperature of the matter? Let's look at our heat to temperature graph for water as an example. Now, if the task you need to calculate asks for the amount of heat to increase the temperature of ice, then you'll be working in this area with only sensible heat and multiplying the weight of your ice in pounds times the specific heat of ice, about 0.5, times the amount of temperature change that will take place in the ice. Another type of question might ask you to melt the ice as well. Depending on the starting temperature of the ice, this could now be a two-part calculation. First, the sensible heat I just mentioned, plus the latent heat of fusion to get the ice to 32 degrees Fahrenheit water. Simply multiply the same weight times the latent heat of 144 BTUs per pound will get you to this point here. Now, if you also had to raise the temperature of the water, then you would have another sensible heat calculation through this area. So you would need to make this calculation and add to the previous two calculations. If you had already elevated the temperature in your previous step right up to 212 degrees Fahrenheit water and now also had to turn that water into steam, then you would need to include a latent heat of vaporization calculation. Simply your weight times 970 BTUs per pound, which will get you to steam at 212 degrees Fahrenheit. And lastly, if you need to increase the steam temperature, you would need to perform another sensible heat calculation using the specific heat of steam, which is also approximately 0.5, multiplied by the weight in pounds again. So, it sometimes helps to draw this out roughly, this graph here, and mark the start and end point of the question. Then you can better see how many steps your calculation is going to require.